Chapter 7 is about hypothesis testing. This is 7.1. So this is where you're seeing if your interpretation holds up with the numbers. So this is just a little joke here. Statistics to test hypotheses and your patients. So hypothesis test is a process that uses all of the statistics that you found to test a claim. Okay, and so we do this all the time. We do it with medicine, psychology, business, politics. You'll see studies if you go on to grad school, especially if you're in the health field. You go on to grad school, you're going to read a lot of studies, and it's going to have this hypothesis testing. Because what happens is, like in this case, a manufacturer claims that their new hybrid car gets a mean gas mileage of 50 miles per gallon. Well, they have to have the facts to back that up. And if you suspect that's not true, you might be able to look into their data and prove it. About a year or so ago, Chevrolet got in trouble. They were doing all this advertisement, especially in the movie theaters, about the safety of one of their cars or the reliability about one of their cars. I can't remember which one it was. Turns out the other manufacturers fought them on that, and they had to stop. They had to pull all of those commercials and make new commercials because their claim was not correct. Now, we still have the problem of we cannot test every single vehicle. We can't test the population. But if we have a good enough sample, big enough and diverse enough, then we can hopefully make a reasonable decision based on the sample as it ties to the population. All right, so I just wanted to remind you here about a normal distribution, right? On the main number line, we have our sample mean in the middle of 50. We're going to add the standard deviation on the right side, subtract on the left side, and then if we standardize it using z-scores, then we're going to have a 0 in the middle. We're going to add 1 each side on the right-hand side to show our standard deviations away from the mean, and then, of course, subtract the standard deviation on the other side. Now, what we're going to be looking for is if we have an unusual claim, right? If the claim gives us data that ends up being outside of the standard deviation and therefore unusual. Now, this problem actually ran some data. They had a sample mean of 47 miles per gallon. They used other data that they had to standardize that, and it came out as a z-value of negative 2.99. So that's a problem because negative 2.99 is way over here, and let me change that to green. And that is more than 2 standard deviations away from the mean. It's actually below the mean. And so that would lead us to believe that this is an unusual event, and we'd have to take a little better look at what's going on. So let's take a look at setting up a hypothesis. And so we are going to look at a population parameter. We're going to call this a statistical hypothesis. And to test this population parameter, whether it's the population mean or the standard deviation or a proportion, we have to carefully state what our hypothesis is. And so we use these two words to denote the two different hypotheses. We use the word null, N-U-L-L, and then we use alternative. And so for the null hypothesis, we're going to have a capital H with a little O here. This is also called H naught, but, or H of O, but we're going to try to just call it a null hypothesis. And then we have, for the alternative hypothesis, it will be a capital H with a small a here. And so that's technically it's called H sub A, but we're going to probably just call it the alternative hypothesis. Now, what's really important with these is that the null hypothesis has to be either less than or equal to, or greater than or equal to. So when we have a null hypothesis here, and let's say we're looking at the population mean, the next symbol before our number has to have an equal sign in it. So it's either less than or equal to, or greater than or equal to. And then the alternative hypothesis, again, we're looking at mean. For this one, we're going to have the complement. So if this null hypothesis was less than or equal to, over here we're going to have greater than or equal to. If the null hypothesis was equal to, the alternative is going to be not equal to. And then finally, if the null hypothesis was greater than or equal to, we're going to have less than. But notice there's no equal to. So if you see equal to, either less than or equal to, or greater than or equal to, that has to be in the null hypothesis. If you see greater than, or not equal to, or less than, that's going to be in the alternative. And we're going to practice a few in just a second here. Okay, so here they are laid out again. We always write the null hypothesis first, and then we write the alternative. Now for K, that's just going to be some number, right? Whatever, the mean is equal to 10. Okay, so K is just a constant, some number. For this first one, the null hypothesis is less than or equal to. Therefore, the alternative has to be the complement, or greater than or equal to. Okay, the greater than. Ooh, I messed that up. So the null hypothesis is less than or equal to. The alternative is greater than, right? That way we cover the whole number line. I'm going to show you that in just a minute. For the next one, we have the mean is greater than or equal to for the null hypothesis. So that means we want the complement for the alternative, and the complement would be less than. And then finally, for this last one, we have the mean equal to for the null hypothesis and the mean not equal to for the alternative. And so that's the complement. Okay, so I know I keep repeating myself, but the null hypothesis has to have an equal to. So less than or equal to, greater than or equal to, or straight equal to. The alternative is going to be the complement. And then the claim can be either one. The claim could be the alternative or be the null hypothesis. And that's where the trickiness is going to come in a little later in chapter 7 of figuring out where the claim is and how to interpret. Okay, so this chart you can look at later if you want, but these are all words we've been practicing all semester. Greater than, at least, at most, exactly, equal to. We're used to these words because we've been practicing them along the way. But in case you want to look at translating those words again, you're welcome to look at that chart. So let's look at some examples here. We've got a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so the proportion is equal to 61%. We're going to change that to a decimal. And that is my claim. So now we want to set up the hypothesis. So we know we have a null hypothesis. We also have an alternative. And for this one, it used the word is. That means equal to. So that has to go in the null hypothesis because it's an equal to. It has to go here in the null. And that means that the complement, P not equal to 0.61, is going to go in the alternative. So for this one, our claim is in the null hypothesis. And then let's come down here and take a look at the number line. So what it's saying is the H naught is only this one in the middle. It's not a less than or equal to. It's not a greater than or equal to. It's just equal to. And therefore, everything on the left-hand side and everything on the right-hand side are part of the alternative because it just says that P is not equal to 0.61. It doesn't say if it's on the left and less than or if it's on the right and it's greater than. So that's how we're going to set up our hypothesis testing. All right, here's another one. A car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, so it says less than, it does not say less than or equal to, so that means I've got the mean is less than 15. Because it's the less than sign and it doesn't have the or equal to with it, it has to come down here into the alternative. So the alternative is mu is less than 15 minutes, and that's my claim. And then the complement is going to be up here in the null hypothesis, and that's that mu is greater than or equal to 15. So this time when we look at our number, our null hypothesis starts it at 15 and includes 15 and heads up because we want greater than or equal to 15. That's our null. For our alternative, it starts just under 15. It does not include 15, and it heads to the left because we want the mean to be less than 15 minutes. A company advertises that the mean life of its furnaces is more than 18 years. So mean is greater than 18, right? More than, that's my claim. Because it does not have an equal sign, it's not greater than or equal to, it's only greater than, it has to go in the alternative spot. So it's going to be the alternative hypothesis, and then the complement is less than or equal to, that's going to be the null hypothesis, right? And so again, when we look at our number line, our null hypothesis is less than or equal to 18. So it includes 18, and it heads to the left because it's all the numbers less than or equal to. That's my null hypothesis. And then my alternative starts just above 18 because I want greater than. I don't want to include 18, but I want greater than. And so that is my alternative hypothesis.